Thanks a lot for joining me so early for this talk. My name is Xavier Gouchet. I'm French. I'm working at Datadog as a senior software engineer and team lead. And today we're going to be talking about benchmarking your application's performance. Before we start, a quick word about Datadog. Datadog is an observability platform allowing you to track status, logs, performance metric across your applications and organizations, and having more than 450 integrations, including Android, iOS, and React Native. But more about that a bit later. So today we're going to talk about performance. Everyone knows what performance are. It's how fast or efficient your application is going to be. And it's especially critical in the mobile world. The first thing is that a lot of users today are not using the latest, best device out there. It's been shown that people tend to change their device about every 2 to 4 years, meaning that your user base nowadays is using a 3-year-old device. Of course, your mileage may vary depending on your target country, target audience, but this is a rough estimate. Also, most people won't have the best network ever. When we're working in Paris, in London, in New York, we're used to have the best 5G connection or Wi-Fi through fiber optic. And so basically, we used to have like very fast and responsive network. But people are also using your application in the countryside where the coverage is not great, or in underground parking lot or lifts where there's no connection at all, or in various situations where they don't have access to the network. And why this is important is because people have a short attention span. When the loading time for a page goes from 1 second to 5, people have 90% more chances of bouncing off of your application, meaning that people are used to things being fast. So this is something that we need to be mindful of when we write an application. And of course, performance like Android are fragmented, meaning that even though we might be developing on the latest Pixel 5 in a 5G area, we still need to make sure that it's going to work correctly on a Samsung Galaxy S8, which was released about 4 years ago, and is still one of the most used devices out there. But when we talk about performance, and this is the main key information about this talk, is that performance must be measured. Because you can't just base your decision on a hunch. You might say, okay, I want to increase my application's performance, but you must know what needs to be improved. Your users are going to be telling you when your application feels slow, when things feel janky, when things feel unresponsive. You're going to know that in your App Store review, you're going to know that in your feedback forms, anything. But it's not their role to tell you what actually is wrong with your application. It's your measurements that can tell you what's not working correctly. And once you figure out what needs to be improved, you need to also have performance values to know when your change, your pull request, is going to improve or degrade stuff. So basically, you need to know before you measure what was the measurements, and after you change something, what's new measurement to know that, yeah, it does have some effect or not. So we're going to talk about your toolbox. You have lots of tools in your toolbox. You have your languages. You have everything to know to help you know that your code works correctly, that the feature that you have behaves as expected. You have your unit testing, instrument testing, manual testing, insert any testing paradigm you love in here. But what tools can you use to make sure that things are working fast and efficiently? Well, that's the goal of this talk. So let's first start at the beginning. You work on a feature on your workstation, and you want to know what's the immediate performance of it. Well, you want to have some tools to give you a full view of the network usage, the CPU load, the memory heap, rendering, everything, you name it. So for that, you have the Android Studio Profiler, which is baked in Android Studio. I'm betting most of you are using that. But you also have Systrace and Perfecto that are external tool that works very, very nicely with Android. So the Android Profiler, it wasn't there in the first version of Android Studio, and it's been greatly improved over the years, especially in the last years. And it's going to be able to connect to any device that's plugged on your workstation or any emulator that you're running. And it's going to give you a real-time graph of everything that's happening in there. At the top, you're going to be able to see basically the user interaction. You're going to see the touch, the user tapping on widgets or scrolling as the pink dots, and with a trail when the user is scrolling and the finger is still on the screen. And the green timeline gives you the navigation through activities and fragments. So when you hover with your mouse, you can still see what activity, what fragment was active at the time. And then you can sync it with what's happening below. Underneath in green, you're going to have the CPU usage, which is basically how much computation you're asking the device to perform. So whenever you have some image processing, some AI work that needs to compute something, serialization, deserialization, and so on, this is what's going to drive the CPU usage. Here on this graph, we see that we have a very huge load just before the blue line. That means that we did some pretty intensive work. Then you have the memory usage, the live RAM memory usage, which means how much data are you keeping in memory right now. We can see that on this graph, it's slightly going up because on this sample application, I was loading a couple of images in memory, and then going down when I release the memory. You have the garbage collection that's helping with that. Basically, whenever you're not using an object or data anymore, it's going to clear this from the memory. But sometimes you're keeping a reference to something, and you're going to not be able to tell this from your code. Here with this, you can detect memory leaks. Basically, you can see here on the right side that there is a plateau of memory. The memory is not moving anymore, but it's a bit higher than the plateau that we had on the left, meaning that we added something to the memory, but we didn't release it, meaning that probably the memory is going to increase over the use of the application until the device doesn't have a memory anymore, which could lead to a crash. Underneath, we have the network usage. This one is pretty self-explanatory. In yellow, you have the upload data. In blue, you have the download. Here in the sample app, I was first loading a JSON file, so a very small network request, and then I had a couple of image downloads, which are a bit higher. This is very useful to know when you're doing network calls that are unexpected, or if a network call is larger than you think it would be. And finally, at the end is very helpful. It's the battery impact of your application. And this one is totally derivative from the graphs above. Basically, the thing that are going to drain the memory is using the CPU and using the network. Whenever you use the CPU, basically you're asking the computer to do some work, and this is going to use the memory, the battery, sorry. And whenever you're making a network request, you're waking up the antenna of your phone. And this is, again, going to drive the battery to go lower. And you can see like on the left, there is a huge CPU load that's connected with a huge battery usage. And then the two networks call are correlated with the battery usage underneath. When you click on the CPU tab, you can have even more insights about what's happening. You have something that's called tracing, and basically it means that the runtime is going to log and record every method call in your application. Meaning that you can know that, oh, here on this example, I have on thread 31 the thread.run method that was called, that called a bunch of methods. And every method underneath is going to be graphed, and you can see every single method call. And you can see that here we had a 8.73 thread run that did a lot of computation. Usually you should not have something that's as packed, as dense as this. So this means that something's going wrong, and you can visually see this immediately. It's also very helpful to know when you're having a loop, when you're having some nested code. You can see exactly how the algorithm go up and down inside the methods. So it's very useful to graph this. And now we are going to talk about systrace. Systrace basically does the same thing as I just showed. It's going to create a graph of every method call and CPU usage and threads of your application. But it's a separate Python script that lives with the Android SDK. So when you're calling the systrace Python script, it's going to start tracing. So it's going to start recording whatever happening on the device that's plugged in or the emulator. And once you press enter, it's going to create a single HTML file that's going to look like this. And basically, this is a file that you can then export, send to someone, store in the cloud or anything. And it's going to give you the same thing. You see here we have like 8 kernels on the CPU. and one of them is used very intensively. And then below, when you scroll down, you can see the threads and see what's happening exactly. So again, you're going to see the method call, and you can dig deep into this. So this is pretty useful if you're not using Android Studio. You do still have systrace available as part of the Android SDK. But the thing is that this UI is a bit hard to navigate into. It's not been improved for the past 5 or 6 years, I think. So it's not the best way to look at things. Fortunately, Google created this Perfecto website, which allows you to load this HTML file and render it in a UI that's much easier to use. You have a search bar, so you can say, oh, I want to see my, I don't know, OKHTTP threads, or I want to see a specific CPU usage. You can add some threads or some CPUs as favorites, and they're going to be starred at the top. And again, you can dig deep into this. But it's not the only thing that Perfecto can do. Basically, it can plug into the Perfecto runtime that's in every device since API 28, which allows you to get a snapshot of what's happening on the device. So you're not just going to have the CPU call, but you can trace also the CPU usage, the GPU usage, the battery, the memory, and some specific Android stuff. And because it's a bit hard so to launch it, to launch this runtime, you have this UI that allows you to say, basically, what I want to do. So you can go in all the categories, click on what you want to track, and then it's going to give you this shell command that you can just copy and paste into a terminal, and it's going to connect again to the device that's plugged in our emulator, API 28+, of course, and it's going to record everything. And you can say, okay, I want to record like for 10 seconds or 1 second, and basically you can have the graph, and then you can load the result inside the Perfecto website. But you can also have more information. So we have this trace object that's available in Android, and it's been available for years now. And you can just call trace.begin section with the name and trace.end section. And basically, you can have deeper understanding. You can say, oh, I'm in a method, and I want to create my own section that's not a method in itself, but I want to know exactly what's happening here to measure things. And once you do that, in the tab, you can add the name of your application and click on this href user space annotation thing. And once you record your traces with Perfecto and load it, you're going to be able to see exactly what's happening. So here in the thread 14.210, you can see that I have the compute cart method that's calling, that have a bunch of sections in it, and each section is traced independently, even though it's not an independent method. So this is a very, very useful tool if you want to graph what's happening inside of an algorithm. So the pros of the profiler systress Perfecto combo is that you don't have any setup required, or almost if you don't use the tracing that I just shown. And you can get the full system information, the memory, the battery, the GPU, the rendering pipeline, everything you want. You also have, I didn't dig deep into this because there are lots of stuff, but you can have the animation threads, all the things that's inside of your application. And of course, you're in a controlled scenario environment. You know what's on the device that you're running. If it's an emulator, it's always going to be like almost empty of anything, like just a factory reset. If it's your own device, you know what's on it, and you know what's running in it. You can use the developer tools to enable or disable some features. But the thing is that the performance measurements are going to be skewed. Why is that? Well, basically, when you're running the profiler, when you're running Perfecto, the device is going to do some computation to grab information about the system, meaning that everything is going to be slightly longer than expected. Also, because you're going to run your application in debug mode, you're going to have some slight performance issue. But that's not an issue. The main thing is that what you want to know with this is when your performance go slightly better or slightly worse. Another con on this is that you need a manual trigger. So basically, when you're running systrace or Perfecto, you need to manually say, okay, I want to record now. and I want to stop now. And likewise, when you're using the profiler, it's going to start grabbing stuff. But again, if you do tracing, you need to say, I want to start tracing now and stop tracing now. And finally, some of the UI and UX might be a bit complex and dense, even though it's been greatly improved over the last couple of years. So you should use it whenever you have a specific performance issue. As I said, you're working on a feature and you want to see exactly what this specific feature you're working on is doing on the device. It's also useful when you want to optimize a specific part of the code or when you want to debug a tricky algorithm because you have nested loop, you can have concurrency. So with tracing, you can see exactly what's happening on each thread and see, oh, I'm calling those methods at the same time and this is where my issue is lying. If you want to go further, on any device that has API 28+, as I said, you have this perfect runtime, meaning that you have everything on the device to grab those traces. Meaning that if you go into developer option, you have this system tracing tab here, where you can actually enable the quick tile setting here. And basically, whenever you're on the go, you're not on the workstation, but you're using your application. And let's say you are on the subway, and the subway goes in the tunnel, and you're losing connection, and then you see something weird happening in your application. You want to know, oh, what's happening here? Basically, you can press the record button here. It's going to record something. It's going to store it on your device. And when you get back to your workplace, you can then plug your device in and get back the trace that you recorded, even though you are not next to your computer. So it's very, very useful. So now you develop your feature, and you push your PR. But sometimes you want to make sure that the performance of this feature stays the same along the way, because as we know, you have a large team, everyone working on the same features, and some code is changed, you have refactoring happening, and you want to make sure that the performance is always good. So what we want to do next is to have a way to measure the time performance of specific operation, and possibly have a way to control that even after the feature is shipped. So to do that, we're going to use the Jetpack Benchmark library, which is an amazing tool to measure things. So it's very useful, very easy to add it to your Gradle script. You add this Android test implementation with the library name. You just need to change the test instrumentation runner. And with this, you can create your own class based on the Android JUnit class, JUnit 4, sorry, and add a rule. So if you've done a bit of instrumentation testing, this is very familiar. It's just another specific rule for benchmark. And once you do that and you create a test method, basically you can have this benchmark rule.measure repeated. What it's going to do is it's going to take whatever is in the block that you give it, and it's going to run it again and again and again, like 100 times. And it's going to measure each one of the run of this block. So whatever is inside is going to be repeated. It's going to measure the timing of all of this, and it's going to give you some statistic about that. And then possibly you can have because it's repeated, you need to clean the state before you run the do some work methods. Maybe you need to create some data to feed to the do some work method. But you don't want those to be measured. So you have a way to say, okay, I'm going to run those blocks inside of it with the timing disabled, because the only thing I want to measure is the do some work method. And once you do that, you do your connected check, you are going to have this specific UI happening on the device or emulator. And in the end, you're going to get a JSON file that has the full timing information in nanoseconds. It's going to look a bit like this. You're going to have a bunch of objects. Each one is going to be is going to have the name of the method, the name of the class, the test class, and then you're going to have this metric object that can have the shortest run, the longest run, and the median one. So you're going to have a bunch of information. And then you're going to have an array with every single run timing in nanosecond, meaning that if you want to do the arithmetic mean or the geometric mean or any statistic analysis of each of the run, you're going to know exactly what the outliers were and what the average one was. Meaning that you can know exactly, oh, whenever I run this on this specific device or this specific emulator, this is going to take, on average, this long. And the good thing is that, of course, you can run it in CI, even though emulators are unstable, so if you can just use real devices, we have lots of ways to have device farm in the CI nowadays. And it might need some tweaks in the Gradle config, but I have some links for a blog post to explain how to do that in the CI as well. And once you have the JSON, basically you can export that and just graph the evolution of the performance. So you can have a way to see, in version 1.8 of my application, the performance the timing went down, meaning the performance went up. Or you can even add something to fail if the measurement exceeds the threshold. This is actually something that we did. Basically, whenever we had a method that was called a main thread, we would measure this method to make sure that it would not block the main thread and it would not have some jank in the UI. So one of the good things is that it's very accurate and reliable and consistent because it's going to run things a lot of time, meaning that even though you might have some flakiness in the information, on average, it's always going to give you a reliable and consistent result. And because you actually say what's going to be in the code block, you can measure anything that you want. So that's very nice because you can tell, I want to measure exactly this. And it can be as high or low level as you need. So it can be just one tiny feature, one tiny just method, or it can be like a full-fledged feature that you want to measure as a whole. The cons is that to have the most accurate result, you better run it on a real device. And even better, run it on many different real devices, one Pixel 5, one Samsung S8, or other devices to have a large panel of information. Also, the feature to be tested must be repeatable. That's the main thing. It's going to repeat calling the same method again and again and again, so it needs to be repeatable and called from code. Lastly, it can take a long time. Again, it's repeating the same method call again and again and again, meaning that you're going to have a very large runtime for this feature. So it can take a long time in CI. Usually what you want to do is have it running every night and not on every PR, but that's your setup. You can do whatever you want. So you can use it whenever you want to monitor critical part of your logic in CI. If you know that, something is very important, you want to make sure that this one, at least, is never going to go above a certain time. Also, when you're refactoring a specific feature, as I mentioned, you make a refactoring and you say, I'm going to measure it with this benchmark tool first, then I'm going to refactor, and then I'm going to measure it again, and then I'm going to be able to see what improvement I added during the refactoring. And as I mentioned, this is very useful when you're writing code that executed on a main thread because the main thread is the most critical one, so you don't want to block this for more than a couple of milliseconds. If you want to go further, there's an official Gradle plugin to log the CPU clocks. This needs the root, but basically what's happening is on some devices, the CPU clocks can be changed to update the performances. The thing is that you don't want this change to happen while you're running the test because it's going to skew things either higher or lower. So you want to log them, and it needs the root, but it's going to give you more accurate results. Also, you can use some CI script to fail on high measurements to say, if something is longer than, 1 second, then this is something very wrong, and I want to block the PR. So now you have something that's measuring things in the CI. You have a tool to work when you're working on new features. But then, you're going to ship your application. So what's happening then? How can you measure what's happening for your real users? That's the thing. You have some tools to help you get performance and runtime information from the production environment. So from your real users as they're using the application on every device that they might own. So for this, you have offerings that are called real user monitoring. I'm going to talk about Datadog because this is where I work, so this is the one I know best. But you also have error tracking and Android vitals to help you get some information about that. So Datadog SDK, very easy to add. We have a bunch of integration with Kotlin, RxJava, Android NDK, and lots of other features. And basically the gist of it is that whenever you're going to add this, you're going to have a dashboard that shows you what's happening whenever a user is looking at the screen. So you're going to see whenever there is a network request, user action, errors happening, and so on. And you can even use that for analytics, even though that's not the topic here, but you can basically see that, we have some users dropping off of the application after the catalog screen, for instance, which means that maybe there's something wrong in the UI. but you can also, maybe it means that there's an error that some people can't just process through the journey in the application. So this can give you some insights to say, okay, where do I need to look in my application? One of the cool features too is that you can have tools to help you know what's wrong with your network request. Basically, when you're going to do your testing in the CI, you're always going to be doing this with mock servers, meaning that if something goes wrong in your application, you're not going to be able to have the full integration in your CI, not necessarily. And here we have an example of an app where the request returns 500. Well, from your application, you know that it was on the checkout screen, and you can actually dig down to the load balancer, the microservice, the database call, and you can see which API in the backend actually failed your application. But then talking back about performance, we have a bunch of things that are called mobile vitals that allow you to know whenever your application is running, what's the refresh rate. So basically when your application goes janky, you're going to have some alerts that say, hey, this screen is only refreshing at 27 frames per second, which is very low and it's going to feel janky for the users. You can see how much CPU you're using in a specific screen. Meaning that if one of the screens is doing a large computation, you're going to be able to see about it and see that, oh, this might have an impact on the whole device. And finally, you can also track the memory inside each of the screens to know when some screens are using too much memory that might lead to an out-of-memory error and a crash. Going further, one of the worst things that might happen for user is the application not responding screen. Basically, your application is doing some work in the foreground, in the main thread, and it's not stopping. And basically, the UI just don't respond anymore. It's frozen, and then the user gets this pop-up that say, oh, your application is not responding. Do you want to wait? Do you want to close it? This is something that we can track, and you can have this. And even better, you can even see the stack trace of what's actually blocking the main thread. So basically, we have here in this CardView model class here, a run method, and we even have which line it's happening in, that tells you, oh, this is the one that's blocking the main thread that's causing this ANR to happen. Talking about stack trace, you have, of course, all the error tracking tools. We have it in Datadog, but you can also find this in Crashlytics and Sentry and so on, telling you that, well, you have a crash that's happening, and that's happening in mostly in version X or Y of your application. But what's nice is that you can also see those errors happening in context. Meaning that, well, when you see a crash happening, you can actually go to the session and see, oh, the user loaded the home screen, and then there were a bunch of errors loading some resources, and eventually one of the requests failed and crashed, and this is something that you didn't take into account inside your code. So real performance monitoring is also very useful because it can help you solve real use cases on real devices with real network conditions, meaning that it's going to give you some situations that you never thought could occur. Also, you have the real data across all your user base, meaning that you can see some trends of the usage and of the performance of some things. Like, for instance, when you think that the key thing that you need to work on for the performance is a specific method, and actually that's not the one that's run the most, but it's another one that you thought, that, yeah, this is just a small method. It's not bad, but this small method is run like 1,000 times whenever a user opens the app. So this is the one that's actually going to be the most critical to improve. The cons of real user monitoring is that to get some good trends, you need to have a large enough user base to have relevant data. And of course, you can't measure anything. This is something that we are very mindful of because basically this is running on real users' devices. So you don't want to degrade their performance while measuring them, of course. So this is a trade-off that you need to have. So we're trying to measure just a few things that are going to be helpful to get a good view of what's happening without impacting the application that's running. So you can use it to monitor key aspects of your application when it's running in the wild. It's also very useful to understand how the performance and crashes are going to impact the user's journey. Also, it's very cool to do A/B testing and filter flags analytics. If you've seen Antoine's talk yesterday about testing things and experimenting things in production, it's very useful because you can flag each run of your application with an A/B test information or filter flag, and you can then get trends to say, oh, people with this feature or this version of the A/B test have better performance. They're using the app. They're interacting more about the application. Rather than this version, basically you're going to have all your information inside the same tool. If you want to go further, the library is completely open sourced on GitHub, so you can give it a look. We do also provide logging and tracing. So I mentioned tracing with systrace earlier, where you can say, oh, I want to know how long this method is taking. Well, you can actually do that in a runtime application in the wild and get some trends to say, oh, on average, this specific method is taking 500 milliseconds, or it's taking 2 seconds, and you can have this across all your users. And there are more features coming soon, but you need to keep posted about that. Wrapping up on this, you have a few key takeaways. First thing is measure twice, cut once. This is a saying that comes from woodworking, where whatever you want to cut, a piece of wood to do some furniture or to do some carpentry or anything, you always measure it twice and sometimes thrice, because you want to be sure about where you need to cut things to make what you want to do work. And this is the same thing here. Like I said, when you want to make some performance improvement in your application, you first need to know where to cut, where to look. Here, I showed you a bunch of tools that you can use, either while you're working in the CI, in your users' devices. You need to find which tool you need to that's most relevant to your use case and to know what you need to improve. So using the real user monitoring, you can see, okay, something is wrong in this screen. Something is wrong in this particular area of my application. And then you can use benchmark library, or you can use profiler to say, okay, I'm going to fiddle with this feature and see what's exactly happening. And then always analyze your measurements before taking action. Again, you're going to have measurements is cool because you can make graphs, you can have a bunch of numbers. You need to understand where the numbers come from before taking action. Sometimes it's very easy to say, oh, this method is taking a long time, I need to improve it. And then you're going to look at it and say, oh, actually it's normal, it's taking a long time, and there's no real way to improve it, and there's no need to take some time to improve it sometimes. Here are a bunch of useful links. We have the UI Perfecto Dev website that I mentioned above. We have a bunch of links about the Jetpack Benchmark library and blog posts to make it work with the Firebase Test Lab, which is very useful. And the link to Datadog's open source app repository on GitHub. And everything is going to be on SpeakerDeck, by the way, so the slides are already up there. Thanks a lot, everyone, for your attention. And you can reach us on Twitter and every social network out there. And if you have any question, please let me know. Thanks a lot.